Hi Algebra 2, this is Unit 6, Lesson 9, and today we're going to talk about modeling with quadratic functions. So quadratic functions are used a lot in real-world applications. Today we're going to see them used to predict something. So here are some helpful hints to solving quadratic word problems. Make sure you know what the different variables represent and the units being used. So if I'm talking about a maximum or a minimum, maximum the greatest, lowest, optimum, those might be some keywords that you might see. The axis of symmetry, x equals negative b over 2a. You're going to use that, and then you plug it in to get the y. So that will give you your maximum or your minimum point. The zeros are the solutions. So that might be like when it hits the ground, or they might ask you for the value of the function as 0. So you make x equal to 0 and you solve for y. The y-intercept might be the initial or the starting point. So you make y equal to 0 and you solve for x. And if it's an inequality, look for words like at most, at least, above, below, and they're going to be asking for an interval. When you're solving graphically, you're going to use your calculator, of course, and you're going to put your equations into y1 and y2. You're going to have to figure out the window, so we'll talk about the window and some of the problems that we're doing. And then you're just going to sketch it on paper and label. You can write down any calculations that you use, label your sketch, and state your answer to the problem as a sentence. All right, so let's look at a problem. An object is fired upwards with initial velocity of 112 feet per second. Its height in feet above the ground is a function of time in seconds since it was fired is given by this equation right here. So h of t equals negative 16t squared plus 112t. So right away, you should know, number one, because this negative sign right here, but this is going to look like this. So basically I have an object that's fired upwards, so it's going to reach a certain point and then it's going to come back down. At what height was the object fired? So I have the word height there. So I'm really talking about my y-intercept. So I'm going to plug in h for 0 for x. So let's see, we're going to have negative 16 times 0 squared plus 112 times 0. Well, 0 squared is 0, and negative 16 times 0 is 0, and 112 times 0 is 0. So basically, I'm talking about 0 feet. That's the height that the object was fired at. All right? Let's sketch a general curve of this equation below. I already sort of did that up there, but let's put it on a graph. Okay, and I'll change the color here for my graph, but we know that it looks something like this, and then it comes back down. Now we're going to have to add in some points, and we'll do that by finding out the points that we need on C and D. Algebraically, find the time that the rocket reaches its greatest height and the maximum height. Label these on the graph that you drew in part B. All right, so the greatest height is right here. And that's going to be my turning point. So remember, to find that point, I'm going to use my axis of symmetry. So I got my turning point. To find the x-coordinate, it's going to be negative b over 2a. So that's going to be negative 112 over 2 times negative 16. And that's going to be 3.5. Now that's my time. Okay, so that's seconds that I'm talking about. And then I want to find the max, okay? So I'm going to plug in 3.5 into my equation to find my y. So negative 16 times 3.5 squared plus 112 times 3.5. And this again is to find my max, my h max point. This here was to find my t, my time, my x coordinate. All right, so in your calculator, negative 16 times 3.5 squared plus 112 times 3.5 is 196. So this turning point right here is 3.5 comma 196. All right, so we got 1 point right there. Algebraically determine the time when the rocket reaches the ground. Label this on your graph. All right, so basically I'm trying to find my x-intercepts, my zeros, my solutions. I'm trying to find these points right here. Well, this one I guess I already know on the left. That's just 0, 0. But so let's 0. I'm going to set y equal to 0. Okay, and I'm going to solve this. I'm going to factor out a negative 16t. I hate t's because they look like plus signs, so I'm going to make them look more like a t. So I'm left with t minus 7. And so basically negative 16t equals 0 and t minus 7 equals 0. So t equals 0 is one solution and t equals 7 is the other solution. So this is the one that I was really looking for here. So this right here is 7, 0. And this right here is 0, 0. Okay, and that's all I need. So we're all set. We got our sketch now and we have our points labeled. All right, let's look at another problem. Exercise 2, a skateboard half-pipe ramp has a shape in the form of a parabola whose equation is y equals 0.06x squared minus 1.2x plus 7. X represents the horizontal distance across a 20-foot wide half-pipe, and y represents the ramp's height above the ground in feet. With the help of your calculator, sketch a graph of the half-pipe below. Label its height at its endpoints and its minimum points. All right, so this has a positive x squared. Okay, so my parabola is going to open upward. All right, and we're going to have to figure out this point right here. And then I'm going to go, whoops, down and up. I would put this in my calculator just to get a general idea of what it looks like, how skinny it is or how wide it is. So in your graphing calculator, you're going to put into y1 0.06x squared minus 1.2x plus x. All right, and this is a 20-foot wide. So basically, I want to look at my table. So let me put this into my calculator right here. You guys are doing the same on your calculator. So I have y equals 0.06x squared minus 1.2x plus 7. I take a peek at my graph. I have to change my window on my calculator because I had changed it before for another problem. Actually, the next one we're going to do, I have to change my window. So that's why it was changed. All right, and if I look at my graph, I can take a peek at what it looks like. And then I'm going to look at my table. All right, so obviously I don't want any negative values. All right, there's nothing to the left of my y-axis. So I'm going to look at everything 0. So it's 0, 7. So this point right here is 0, 7. Okay, I'm going to look for my turning point. My turning point is at 10, 1. So this right here is 10, 1. And how am I getting all this? I'm getting this from my table. So I'm looking at my XY table right here. All right, and 0, 7 was a point. And then I have 9. I'm just going to write down some of these just so you can see. 9 and 1.06. I have 10 and 1, and I have 11 and 1.06. So I can see that 10, 1 is my turning point right there. And I'm doing everything up to 20. So at 20, I'm at 27. 20, 7. All right, and there's my graph. So that one wasn't too bad either. The one that's a little bit more difficult is the last one because I'm going to have to change my window on it. All right, so let's look at that last one that we have. The Crazy Caramel Corn Company has determined the percentage of kernels that pop rises and falls as the temperature of the oil that the kernels are cooked in increases. It's modeled this trend using this equation. So here's the equation that you're going to put into your calculator. All right. P represents the percent of the kernels that pop, and T represents the temperature of the oil in degrees Fahrenheit. So let's algebraically determine the temperature at which the highest percentage of kernels pop. All right, so this we should know it's negative, so it's going to look like this. So I want that turning point, the point at which the highest percentage of kernels are popping. All right, so I got, again, it's negative b over 2a. So it's going to be negative 2.8. I'm doing this algebraically. Over 2 times negative 1 over 250. Obviously, I would put all of that into my calculator, negative 2.8. divided by, parentheses, 2 times negative 1 over 250, and it should be 350. Okay, and then I'm going to try and find my max. So now I'm going to have to plug in 350 into my equation. So negative 1 over 250 times 350 squared plus 2.8 times 350 minus 394. And that's going to give me P, which is the percentage of kernels that pop. So this whole thing goes into your calculator, and that gives me 96% of the kernels that pop at that time. All right? So using your calculator, sketch a curve below for when P is greater than or equal to 0. Label your window. All right, so we're going to have to talk about the window, but basically we know what the curve looks like. All right, when the temperature of the oil is 0, nothing's happening at all. So this is going to be over here somewhere. And P represents the percent of kernels that pop. We just found out that that turning point right here was 350, 96. So when the oil is at 350 degrees, 96% of the kernels pop. So this right here is 100, because it's not going to be greater than 100%. Now, I need a window. This point, the x-coordinate is 350. So on your calculator, I want you to plug this equation into y1. All right, so negative 1 divided by 250 x squared plus 2.8x minus 394. Now you need to change your window. So look at the window button. All right, I'm going to change my x from 0 to, let's say, 700. Okay, because 350 is sort of in the middle right there. And I'm going to change my x scale is normally 1. Let's go by tens just so I can see this on my calculator. All right. I'm going to leave my y minimum as negative 10 only because I do want to see a little bit below the x-axis, because I'm going to have to find these points right here, the points of intersection. All right. So I'm going to leave my y min as negative 10 and my y max is going to be 100 because, again, I'm not going over 100%. And again, let's have my scale at 10. All right. So now if I hit my graph button, I can see that. There we go. There's my parabola. I can see it upside down. And C and D are going to have us do a couple things with my calculator. So C wants us to use the 0 command on your calculator, determine to the nearest degree the two temperatures at which P equals 0. Okay, label them on your graph drawn in part B. So basically, I'm trying to find these points right here. I want to know where P is equal to 0. So I'm going to use the 0 command. So I'm going to, if you hit second, calc. So the equation's already in there, and I'm hitting second, calc. All right, and I'm going to go down to 0. And I'm going to hit enter. Now here's the deal. You're going to have to set up your left bound and your right bound if you remember doing this. So you're going to use those arrow keys. And basically what I'm doing is, all right, let me draw this back in purple. This actually continues, all right? And I'm trying to find those red points right there. So let me get a new color. So basically you're going to go below right here and you're going to go above. So that's going to be your left bound and your right bound. So left bound and right bound. So the two blue dots. So I hit left bound, I hit enter, and then I use my arrow and I go a little bit above that point of intersection and I hit enter, and then it's going to say guess, and you're going to hit enter, and it gives me my point of 195.08. We'll round that off. So that's 1 point of intersection. And now I got to do it again. I'm going to hit second, calc, and again 0. And I will need to find my other point. Second, calc, 0, enter. Okay, and I'll pick a new color just so you know I'm doing a different point right here. So let's pick this green. So I'm going to come all the way over here with my arrow, and I'm going to go above, and I'm going to go below. So I'm going to hit left bound, and I'm going to hit enter, and I'm going to hit right bound, and I'm going to hit enter. Okay, so I got to use my arrow keys, and I'm going exactly where I put it doesn't have just on either side of that point of intersection. So I got left bound, and then I scroll below it, and I hit right bound, and I hit enter, and I've got 504.9, and that's my other point, 504.9. Okay, so those are my zeros. So the red right there, I now know is 195.08, and this one right here is, I'm just going to round it off to 505. Okay, this is just a sketch. All right, if a typical batch of popcorn consists of 800 kernels, how many does the Crazy Caramel Corn Company expect to pop at the optimal temperature? So remember, I have that I was popping about 96% at that optimal temperature. So if I have 800 kernels, 800 times 0.96, I expect 768 kernels to pop. And the last one, for a batch of popcorn to be successful, the company wants at least 85%. At least 85%. Okay, so that means it actually wants greater than or equal to 85% of its kernels to pop. Write an inequality whose solution represents all the temperatures that would ensure a successful batch. Solve this inequality graphically to the nearest degree and show your graph below, labeling all relevant points. All right, so in Y1, we're going to put in, well, you already have it, the negative 1 over 250 t squared plus 2.8t minus 394. But actually now I want it to be greater than or equal to 85%. So this right here is going to be my Y2. All right, so Y1 is going to be the equation that I already have in there. My Y2 is going to be just 85. Then look at the graph. So now I have two lines. I have my parabola, and I have this line right here, which is at 85%. This is where, right there, y is equal to 85. All right, so basically what I want to find is I want to find the point of intersection here and here, because I'm trying to find the optimal temperatures that would ensure a successful batch. So I'm really trying to find this right here, that inequality. Remember, it's going to be everything in between there is going to give me my optimal temperatures. So what I'm going to do is in my calculator, you can look at your table, except you're going to be scrolling quite a bit. I can hit second calc, and I'm looking for those points of intersection. So second calc intersect. So second calc intersect is number 5. All right. And then I just need to come over here to the first curve, that point of intersection. And it's going to give me, my point is 297.5. Okay, and then I'm going to do it again, second calc, and I want my point of intersection, but let me come over to the other side. Okay, and I get 402.4. Okay, so I did it on either side of those points of intersection. So basically, it's 298, because I'm going to round it off, and 402. So if my temperature is between 298 and 402, I will get 85% of my kernels to pop. Okay, and that's it.